Welcome to Data Analysis with Python. And in this video, our focus is going to be on merging, concatenating, and reshaping data, right? So straight we go for the definitions. What does it mean to merge in data analysis? Of course, we are still using Pandas all the way. And of course, we are, beginning to delve into Pandas, into Seaborn, and of course, we also get to use NumPy once in a while when the need arises. Uh, and you see the reason for especially using something like Seaborn at this point in time, though we are not talking about data visualization yet. Okay, so to merge is simply to combine multiple data sets into a single data set based on common columns or indices, typically using operations like joins. Now, for those who are familiar with SQL, you know that we can have all kinds of join. We have outer join, left join, right join, and things like that. So that kind of idea happens there. So this is just to tell us that you can join two data sets together as far as they have a particular column in common. So we are going to see how this happens very soon. Now we talk about concatenating. Concatenating is simply to append data sets along a particular axis, be it a row or a column, to create a larger data set. And this is often used when data sets share the same structure. So you can concatenate data sets that have the same structure. And then we have reshaping. So if you want to reshape data, you can transform the structure of the data set, such as pivoting, melting, or stacking to reorganize data for analysis or visualization. So sometimes if you're dealing with especially object categorical variables, right? Pivoting may be helpful to for you to have a clearer picture, just like the idea of cross tab we saw yesterday. I mean, we saw in the last video rather when we're talking about feature engineering. Okay, so of course you don't get to do anything until you load your data set. And just like I've told you, you can find data sets. You can self-generate data set by just maybe creating a Python dictionary and turning that to a data frame. We are going to see that here. We've seen it a couple of times. Another place you can get data set from is you can get it from Python. So some data sets they are embedded in some Python libraries like Seaborn, like scikit-learn and all that. So today we are extracting data set. We are getting data set from Seaborn. So that's why if you see Seaborn being imported here, it's because we need data. The four data sets, I mean the three data sets we are using here, apart from the other ones, they are Python in the data set that we can access through Seaborn. And the three data sets are the tips data set, the penguins data set, and the flights data set. So I have just one liners to explain the nature of those data sets. For instance, if you talk about the tips data set, it is a data set containing information about restaurants, including the total bill, that people paid, the tip amount. This is like an American setting where tipping is a culture. It is so embedded that if you don't tip, it feels like you're rude. Whereas in a place like Japan or Singapore, if you tip, you are rude. In America, if you don't tip, you are rude. But in Singapore and Japan, if you tip, you are rude. So you have to understand the culture you're operating in. So this is an American setting for sure, where tipping is a normal thing to do. Then we also have the gender, the smoking status, the day, the time, and the party size, commonly used for regression and categorical data analysis. So the tips data set is going to be very good for categorical data analysis. And I guess things like okay, when we get there, we'll see. So here, now I'm importing pandas as PD as usual, and I'm importing Seaborn as an SNS just because the data sets I'm accessing, like tips, penguins, and flight data sets, they are all going to access it through a function in Seaborn called load dataset. So the load dataset function is a function you can access from the Seaborn library, and you have these datasets, the tips, penguins, and flights. So let's see this. So here I'm loading pandas. I'm importing pandas as PD, importing Seaborn as SNS, and then I want to load the dataset from Seaborn. So the first dataset I'm loading is actually the tips dataset. So we are calling that. So the variable name we are sending to that is tips. I could as well call it DF or DF1 or like we've been doing, but I call it tips here. So whatever you call your data frame should be something, it should actually be something descriptive enough for you to know what exactly it contains. So that's why it's not a bad thing to call it tips. And then the way to upload to mount the data set instead of using something like pd dot pd.load underscore CSV or something like that. So here you just do SNS dot load underscore dataset. Like I said, load underscore dataset is a function that you find in Seaborn. And you can only access it through Seaborn like that. And then you now call the name of the dataset, which is tips. And then line 6 helps us to visualize it. So I'm not using printed so that we can actually see the neater format. Again, to reiterate that idea of print. So to print now, you do this, and then it takes a bit of time. It mounts Pandas, it mounts Seaborn, and then it shows you this. Well, while this looks great, all right, I prefer it better without the print, but this only happens if you don't have something coming after that. So you can see this is neater, like a bit more formatting and makes it look neater. So you have 244 rows and 7 columns. Of course, you can go further to say maybe we can see up to 50 data points at the same time. So we can just do tips.head 50, and then it shows us the top 50. So you can see total bill, the tip paid, sex, I mean, that's the gender, smoker, no or yes, day of the week, dinner, time. Is it for dinner? Is it for, okay, if we look at the tail, maybe we can see if we have people that come for lunch in that place. So, but this top 50 talk about uh dinner, okay? So yeah, we have people that come for lunch for sure. Okay, from here now we see all that. So you can use head and tail. So this head tells you, give me the top 50 data points. That's what this is doing. And tail gives you the last 50. Okay. So that's what we have right here. And if you just want everything to show, once it's more than 50, it shows you the top five and the last five. So if you just use tips alone without using head or tail, so it shows you the last five, the first five and the last five, basically. Okay, so let's look at the penguins data set. So it's a data set from the Palmer Archipelago detailing measurements of penguin species like their flipper length, their bill depth, etc. And it is used for classification and exploratory data analysis. So again, just like you loaded tips data set, you can load the penguins data set like that too. So here now you don't have to import anything from anywhere. I mean, you don't have to. You're not uploading a CSV or JSON or Excel file. No, you're accessing this through Seaborn. So the penguins dataset, we call it penguins, and then we say sns.load dataset penguins, and then we visualize it with line 2 here. So if I run this, you also have that. So I mean, this is particularly good for if you want to do data cleaning. So you can see some not available values and things like that there. So this penguins dataset will be very good for exploratory data analysis and of course for data cleaning and preprocessing. So let me see the top 50 since we have 344 rows and 7 columns. So look at the top 50. We have the species, their island, the bill length, the bill depth, the flipper length, the body mass, and the sex, like that. So you can see some not available values, NaN. So you may need to clean that if necessary. But if what you're doing does not require that, then you don't have to worry yourself then. Okay. So we have this now for the penguin. So we've described that. So another data set to be using that will be accessing through Seaborn is the flights data set. So it is a time series data set. Now, a time series data set has dates and then it has other things following. So it can have full date like day, month, and week, day, month, and year, or just year, or month and year, or whatever. So it has a factor of time. So a time series. Oh, I've been forgetting to zoom out like so this is the first thing I did to load the tips data set. Okay, and then this is the next thing I did to load the penguins data set. Now I'm talking about the flight data set now. So if the flight data set is a time series data set showing the number of airline passengers per month from 1949 to 1960, and it's useful for trend analysis and time series forecasting because this one it has date attached to it. Okay, so this is what I use. And because I can no longer run up there, so I just use Control Enter, or I think Shift Enter. Control Enter works. Yeah, Control Enter works. So we have this flight data set, and let's see, it has 144 rows and 3 columns. The 3 columns are year, month, and passengers. So we want to, just explore this a bit more. We want to see the top 50 data points in this case. Okay, so you have the top 50 like this, the passenger numbers and things like this. So you have all of them. Okay, so that is the flight data set. So we are using the tips, penguins, and flight data set. Now, let's talk about concatenating data frames. Now we're beginning to talk about what really brought us here, concatenating and all that. If you remember, the topic we are considering is merging, concatenating, and reshaping data. Okay, so concatenating is coming first. You're going to see merging afterwards. So talking about concatenating, right? Um, so it's a very common idea in even matrices. You can join two matrices together as far as they have the same number of maybe rows or columns, depending on how you want to do the joining. So if you want to join at the top or by the side, if you want to join by the side, right, you need them to have the same number of rows. If you want to join at the top, you need them to have the same number of columns. So this kind of idea is very useful in this case. So when we want to concatenate data frames, so we use pd.concatenate. That means that concat is a function that you find inside the Pandas library. So imagine that we have monthly tips data and we want to combine them into one data frame for analysis. So we want to extract only the months for the tips data. Now look at the tips data. So we just want to extract something for January, February, and things like that. So we want to make that happen now. So what we do here is we want to simulate monthly data slices from the tips data set. So what we're going to do is to say January is equal to tips dot. So you locate from the beginning to the 50th, all right, and then you copy that out. So what this line two is doing is to replicate to take the first 50 rows of the tips data set and copy that out without affecting the original data set. I've talked about copy in the first 2 or 3 videos of data analysis itself. So, and then we're now saying those 50 data sets, we are now saying we are creating a new column for it. And we're calling that new column January. Okay. And then we have another one. We can actually, let me see. Okay. Well, I can just do that in passing where print, I just say print January. Okay. Print January. And then I silence this. Okay, and then I run this. So print January. So it shows up. So you see it has created the month January, all right, for the first 50 data sets. Okay, so I go back and undo this. So it's from 0 to 50 to 49, that's January. So we are taking 50 to 100 to now be February. That's what basically is happening here. So 0 to 50, 49 here, and then 50 to 100 is now February. That's what we are assigning. So if I take this out and then I just come here and say print for me, uh, the print for me February. Okay, so that'll be from the 50th to 99th. Like we start from the beginning. We don't get to the last one. So if I enter this now, so you see February, it starts from 50 and it stops at 99 because it doesn't get to the 100, as we know how Python does. Okay. So with that in place now, so I come back and so you have visualized this. Those new columns have been created. It was not in the original data set, but we want to concatenate. So we now want to combine the combined tips will now be PD concatenate the January and February data sets. All right. And we don't care about index in this case. And then we want to check the combined data frame now. So I just press control or shift enter. I think shift enter also works. Yeah, shift enter does the same thing. So this is what happens now. So we now have total bill, tip, sex, smoker, day, time, size, month. So you see first 5 shows January because January is from data point 0 to 49, while February is from data point 50 to 99. So you see that here. So now we have 100 rows and 8 columns. And it is not exactly like what we had for the original tips data set, but you can actually make things like this happen. So with this now we have concatenated this January and February data sets into one. And this is what we have now. Okay. So next we have the merging data frames. You can merge data frames using pd.merge. So merge is a function in the pandas library. So here we want to simulate a scenario where we merge tips with customer based on customer ID. So it's more like maybe you have a data set where you have the customer names and their IDs, and then you now have the main you now have the normal tips data set which did not have customer ID. I mean, we did not have customer information like that. So you can just you can create a customer ID, or if it already had a customer ID, you can you can now join the two together, and that is merging in this case. So here, we want to create customer data frame with 244 rows to match tips. Tips has 244 rows from what we saw initially. If you remember, if you don't remember, let's quickly look at that. To look at the tips data set, 244 rows and 7 columns. So what we want to do now is that since the tips data set does not have a customer ID, so we can create a new cell like that. But before we do that, we have another data set which now you can now see this is a a data set from you, like self-generated data set. You can quickly just make this up. Or if you have another data set somewhere, maybe in Excel format or whatever format, or you can also extract it from Seaborn, it's also possible. But this one is handmade because we have 244 rows. We want to quickly make as a data frame called customers. With customer ID starting from 1 to 244, we don't get to 245 for sure. If you want to get to 244, you put 245 here. So, and we say customer ID. So it will take number from 1 to 244, and the name will now be customer 1, customer 2. That's why we have for I in range 1 to 245. So customer 1, customer 2, up to customer 245. But if you have a standard data set like Excel or JSON or anything, and you have each customer's name, you can actually put this to, but this is a very fast way of working around this. So we just have customer 1, customer 2, customer 3. But if you want their proper names, then we may also create a list of 244 names. But that's a lot. But so this is a very smart way of doing this. So we create the customers data frame like this because we say customers pd.data frame. So it's automatically a pandas data frame, right? And here we are assigning customer ID to tips. Tips did not have customer ID normally, but if it had customer ID, we could as well. We don't have to worry about this. But now we are now saying tips with new column customer ID, and the customer ID will range from 1 to 245. So with this now, they have this customers data set and this customers data frame and this tips data frame now have customer ID in common. So that can be the basis for joining the two together like that. All right. In this case. Um, of course, they also need to be of, uh, well, these ones don't have to be of the same rules before we can. So concatenation is vertical, right? It's vertical. So it's more like you're putting one on top of another. But when it comes to merging, it's horizontal. So it's side by side. So if it's side by side, then you need them to be of the same number of rows. Okay. So if you're for this joining now, you need them to be concatenation is for same number of columns, while merging is for the same number of rows, if that makes sense. Okay. So in this case now, we have made sure that we have 244 customer IDs and their names, and then we also have to have something similar. We now have in tips dataset now we are creating a new list. We are creating a list of customer IDs that are also 244. So because they have the same rows now, we can merge. So you merge when you have same rows, and you concatenate when you have same number of columns in the two data sets you're concatenating like that. So and concatenation is vertical concatenation, and merging is more like horizontal, like row to row. Okay, so in this case now, you now want to merge or join tips with customer info. So merged tips will now be pd.merge, then the tips dataset which we had originally, and this customer dataset, and we are merging based on customer ID like that. So some kind of left join is happening here. So when we get to SQL, you'll understand this idea of joins like that. So it is more a concept pretty close to joins, right, in SQL. So if I just press Control Enter now, then I get this data set right here. So I have now I have customer ID 1 to 245, 244, and then customer 1 to customer 244. That name thing is just for convenience sake. Normally I should be putting their actual names. So but if I already had a data set that contained that, so you could actually upload an Excel file here as far as it has 244 rows to you still do your merging and it will work perfectly as far as the number of rows are exactly the same for tips and for this new customers data set. Okay, so we move on to the grouping and aggregate data. So here we use group by command. We use the group by function and the AGG function. That's the ag function, the aggregate function. So here, let's aggregate the penguins data set by species and island, computing the average body mass and counts. So it's more like you have taken all the reading, right? Now I want to say, okay, let's look at these penguins according to their species and according to their islands, and then we now want to see the average body mass for each island and the average count of those species for each island. So in this case now, you say group by species and island and summarize body mass. So you say aggregated penguins will now be penguins dot group by. So you're grouping the penguins data frame by species and island, and you're aggregating based on average mass. That's the body mass G, which the mean, right? And then the count, which is also body mass count. Okay, so body mass here, the penguins dataset has body mass underscore G, right? So that's the basis for doing this. Okay, so if we come back here now, and then we now also reset. So after doing this now, we can reset index straight. I've done something about resetting index before, so you don't have to go stress yourself explicitly like that. Once you are creating, so whatever you are creating now, so you just say dot reset index, and the index is automatically reset from 0 to wherever I should get. And then line 8 displays the aggregated penguin data. So this is it right here. Okay, this is it right here. So let me make it small so by the time I run, I can see everything. Okay, I can even still expand because you have just few. So you see now that the Adelie species in on Bisco Island have an average mass of 3709.66, and they are 44 in number. The Adelie species in Dream Island has 3688 average body mass, and then they are 56 in number. Then the Adelie species in Togasen, the average mass is 3706.37, and they are 51 in number. And then the Shinch Trap species in Dream Island has average mass of 3733.09, and they are 68 in number. Then the Gen 2 species of Bisco Island have the highest average mass of 5076.5076.02 roughly, and they are 123 in number. So biggest size, biggest count. So if you're someone researching on penguins, you may have so this may raise your curiosity that why are the penguins on Gentoo of the Gentoo species on Bisco Island, why are they this big and why are they this many? What is happening on that island, or what is peculiar to that species that makes them really that makes them really thrive that much? So that should make you curious to see. To want to that can be like a hypothesis or something that you can form to research further into that concept. Okay, so imagine I may just want to only group by islands. So if I just want to group by islands, I mean by species, I can just remove island and press enter. So now it just tells me, okay, so we're only grouping by species. So the Adelaide species, so again, the Adelaide species is 3,700. That's overall. We don't care about the island or anything now. We just want to care about the species themselves. Okay. So Adelaide 151 altogether across the islands. Chin strap is just 68. Gen 2 is 123. So overall, now we have Adelaide of higher population than Gen 2. All right. But so if you now add island to it, or what if we just want to group again by island? We want to see their body mass, average body mass, and their counts across islands. Okay. So we see in Bisco, so we have the highest number of beds on Bisco Island with the average mass of 4716. And then on Dream Island, so that's beds across all species now. Dream Island, you have 3712 average mass, and then 124 in number, and then Togasen. All right. So you can play with different ones like this. Okay. Okay, what happened here? Control Z. No, like just bring this up. This goes home, and I remove this because I like it to be that neat. Okay, good. So we have this. So across species and island, so you can do this. So we can also create a pivot table, which looks like a kind of cross tab. Okay, so let's pivot the flight data set. This is the first time we're talking about the flight data set. So let's pivot the flight data set to create a summary table showing total number of passengers for each month across years. So you just see it in one blow. So what the table has shown you is different years and months and everything, but this pivot table just shows you everything at a glance, right? So Here, of course, we don't need this because we've loaded this before, so it's not necessary. Even the flight data set has been loaded before, so it's also not necessary. Okay. So again, we have pivot underscore flight. That's the name of our data of our of the new data frame now. So it's just a flight now. That original flight data set we loaded initially dot pivot table. So we are creating a pivot table of it, and we are using our month as our index and our columns to be here. We can also switch it over like we want to see what happens each year across months, something like that. So index is month, columns is year. The values we want to display in the cross tab in the pivot is the passengers, and want to use an aggregate function of sum, right? So we want to pivot the flight data set to create a summary table showing total number of passengers for each month across years, right? So for each year, we say for this month, this is the total number of passengers. Then we display the pivot table as we see in line 11. Okay, and when we do that, so you see, this is something you can relate with better compared to when you have the whole long data set, the way it was initially. So this one, gives you everything at a glance. So in 1949, there were 112 passengers in January. In 1960, it has increased to 417. So you see, if you look at it just overall, it looks like things are getting better over the year for flights. Flights are getting better. I think our flight started around 1930 or 1930, 1940, like that. So it means, when things first start, some people are afraid, like, oh, they don't want plane crashes and things like that. But over time, flights have become very reliable, and the number has increased. So this is 1960. So right now it should be way, way more than this. Okay. So you can do a pivot table where you just see everything at a glance like this. Okay. So then we talk about reshaping with melt and stack. So let's reshape the pivoted flights. So we've done the pivoted flight up there just now. So how do we now reshape the pivoted flight data back to long format using melt? And we can also use stack and unstack for more advanced reshaping. First of all, let's start with melting. So we melt the pivoted flight data back to long format, which the way it was before. So method flight will now be the pivot flights, which this pivot flight you had up here now, we want to make it back into that. So we say pivot flight does reset index, and then we melt based on month, year, and passengers. And then we can see the top 50 of the melted flights this way. So it's back to where it came from. So it means you can take it from the original format to pivot and then take pivot back. So if you want to take a pivoted table back to the original format, you call that melting, and then you use the melt function uh, like that. You use a melt function. Okay. So you can see this is pretty much back to what it was like when we first uploaded the data. And this is just showing the top 50. So we can also stack and unstack. Okay, this is a stack example. So stack example. So, and this is very good for hierarchical data, both stack and unstack example. So the stacked flights now will just be pivot flights dot stack. Okay, and if we enter that, so this now, so it doesn't show it like what we had before. You had month, year, and number of passengers. So here now it says month. So for January of every for all the years, it shows everything at a glance. So you can have an idea of what happens in January. February shows everything at a glance instead of going one after the other like before, like what we had. So here, it's more like January, February, January 1949. 112, February 1949, 118, March 1949. But here now it just shows you January for every year. This kind of information will be useful. So January for every year shows you what it is. February for every year shows you what it is. So this is what we mean by stacked flights here. So you are stacking here using the stack keyword as you see in line 2. So pivot flight does stack. That's what stacking does. To unstack is to take it back to what it was. So it's more like the normal, so the regular pivot table, you are stacking it again. Okay. So that works. All right. So having said that, we come to this is a summary of everything I've been doing so far. All right. So if the task is to concatenate data, so you use pd.concat. So you need pandas you need to upload pandas to be able to concatenate. And a very good example we have seen is monthly tips data, where we use customer ID to join the tips data set with another data set called customers, so which contains customers information, their ID and their name. Okay, and then we also have merge data, and we talked about concatenation that you need data sets. If you're concatenating vertically, you need data sets to have the same number of I think the same number of rows also. Yeah, where you put it on top of themselves. I think that was the same number of columns. Yep. Okay. Then we go for merge data. So we have pd.merge. So you have tips and customers data set coming together there, and we merge the two together. Here you need the number of rows to be exactly the same so that you can merge. If not, the merging will not be possible. Then if you want to group and aggregate data, so you group according to a particular criteria and aggregate based on another criteria, which can give you some very insightful information into what you're seeing. And we use the penguins data set and we group by species and islands, for instance. And you can also have it can pivot data by using pivot underscore table. That so you see, group by and ag, they don't need pandas. They can operate by themselves. So they are functions that stand on their own. They don't need to be called through a library or anything like that. So you can pivot data using the pivot table function, and we use flight passengers by month or year, and you can also reshape from long to wide by melting. So pivoted flight data can be melted. Then we also have advanced shaping like stack and unstack, where we had flights with multi-index manipulation. So just like I keep saying, all my code sheets and data sets are available on Google Drive, and you can access the link in my description box on YouTube. I think on Facebook too. So, but of course, the data set I used today, I didn't import anything from outside. So everything is from Seaborn. So this ones, you don't need any data set. As far as you run the code, Seaborn will help you retrieve the data set. So you don't need to see the data set for tips, for flights, and for penguins to be able to work on it. Just so they are inbuilt in Python. So I'm using all this kind of data sets so you can know how to work with different types like that. So you basically literally don't need to have any if you don't have any data set somewhere to import or to export. But I think it's also good you work with that in case somebody gives you a data set to work on. So that works. So let me know how helpful these videos have been for you. And of course, let me know if there's a topic you'd like me to teach you, a problem you'd like me to solve, or you have a data set you'd like me to work on. Even if you don't have the data set, you can just give me an idea and I'll make up the data to explore, because I mean data is everywhere. Depending on your knowledge domain, you have your peculiar kinds of data sets and how to handle them. So, and there are, as you can see already, there are peculiar ways of handling categorical data sets that have mostly categorical variables, and there are peculiar ways of handling data sets that have that are mostly numerical variables, right? So, also, if you have subscribed, thank you. If you have not, you've been missing a lot already. So, you want to subscribe and hit the notification bell so you can always get alerted each time a new video is released. And be sure to like and share so that more people can have access to this great content I have here. Until I come your way again, keep doing maths right. Bye.